everyone, so we're going to have a look at the common misconceptions from the previous ED homework that you just did at the end of last week. Okay, and there were two quizzes that we did, and this one is the only question that I'm going to do from the first quiz, which was the probability of single events, and then I've got three common errors, common misconceptions from the second task, which was a quiz on tree diagrams and Venn diagrams. So let's have a look at this first one. And for those of you that want to know, that was actually question one of this quiz, this probability of a single event quiz. The rest of it was actually done really well. And this one was the one that if people were going to make a mistake, they made a mistake on. Okay, the correct answer is D, A and C. And the most common wrong answer is B. And what I'd quite like you to do, if you haven't already, if you know you got this one wrong, I'd like you to have a little go at this question first of all, see which answers you get, and then see whether it was one of these two. And let's have a look at why people might have chosen this one and why this one is right. Okay, so let's do this question. So first of all, let's read the question carefully, and some of you are guilty of not reading questions carefully enough sometimes, so make sure you are reading this question carefully. The following possibilities about the outcomes when rolling a fair ordinary dice. So if we look at that, the only outcomes there that can happen on a fair ordinary dice is 1, 2, 3, 4, 5, 6. They're the only things you get when you roll a dice. And what we're asked here is to look at these different events and to decide which of these cannot occur at the same time. So let's have a look at each of these. And I think this first one is the one that tripped people up and maybe caused people to choose this answer, perhaps because people didn't know what Fibonacci sequence is. So let's have a look at this. And if you don't know what Fibonacci sequence is, then you should get this into your notes, please, as well. So Fibonacci sequence basically starts at 1, and then what you do is you add the number that you're on together with the one before it. So here, 1, there's nothing before it, so if I add 1 to nothing, I'm going to get 1. And now I've got 2 elements here, and now I do add the most recent one to the one before. So 1 and 1 is 2. And then I add 2 and 1, which is 3. And then I add 3 and 2, which is 5. And then I add 3 and 5, which is 8. 8 and 5 is 13, etc. And that keeps going forever. So that's Fibonacci's sequence. And if you don't know that, then please get that into your notes, maybe with a little bit of a reminder that you're adding the 2 elements together to get the next value in the sequence. So from a dice then, what could we have? Well, we could have 1, 2, 3, or 5. So from this Fibonacci sequence, what can we have? I'm going to put it back up in the question. We could have 1, 2, 3, 5. They're the only elements that appear on a dice. Okay. A factor of 20 then. So let's look at that next one. Factor of 20. Well, let's just think about our factors of 21 and 20, 2 and 10 if I'm doing them in factor pairs. And again here, on a dice, we can only get 1, 2, 4 and 5. So they're the only factors of 20 that occur on a dice. Rolling a multiple of 4. Well, I'm not going to write that down. Multiple of 4, 4, 8, 6, 10, 4, 8, 12, 16, etc. So your 4 times table. So the only one there that we're going to get on a dice is a 4. And then rolling an even number, well, even numbers 2, 4, 6, 8, 10, 12. But on a dice, they're the only ones. So get your outcomes sorted. Let's have a look at this. B and D, can they occur together? So a factor of 20 and an even number, well, yes, because 2 and 4 are in both of those. So they're common, so that can definitely happen at the same time. A and D, this is our most common wrong answer. So A and D, rolling an even number, and a Fibonacci, well, 2's in the Fibonacci sequence, so there's a common element there. So these two can definitely happen together if you get a 2. And I think probably what's happened here is, as I say, people just didn't know what the Fibonacci sequence was, maybe thought it was odd numbers or something like that. B and C then, factor of 20, multiple of 4, well, 4's common there. And then A and C, 1, 2, 3, 5 from the Fibonacci sequence, 2, 4, 6. So, multiple of 4 here, 4 is the only one. They're not common, 4's not in the Fibonacci sequence, so that's why this one's correct. Okay, let's move on then to the tree diagram and Venn diagram questions. And this was the one that was done the worst. And again, I think it's just really about not understanding the question in a lot of cases. Okay, So this, if people want to know, this is question 13 from the second task. And here, B is the right answer, so well done if you got that. Not many people did. C was the most common wrong answer, followed quite closely by A. So we're going to have a look at why these two might have come up as being the wrong answers and how this one works. So let's get the correct answer first of all. We need to read the question carefully. What's the probability a diamond is picked from, so 52 cards in a pack, what's the probability of a diamond is picked given that the card is an ace, a king, a queen, or a jack? And this word in probability is really, really important, okay? So given, what does that mean? So that means that we're not now choosing from the whole pack. So we're not choosing from that 52 anymore. We're given that we've only got these cards to look at. So all we're looking at, we're only choosing from the aces, the kings, the queens, and the jacks. That's the only thing that we're choosing from. So looking at this, well, what have we got in a pack of cards? We've got hearts, we've got diamonds, we've got clubs, and we've got spades. Okay, so they're the only things we've got. We've got the ace of hearts, diamonds, clubs, spades, the king of each of those suits, the queen of each of those suits, the jack of each of those suits. So what does that mean? That means I'm choosing from 16 cards. So the 4 aces, 4 kings, 4 queens, 4 jacks, 16 cards, and not all 52 cards. That's really important. So the denominator of my probability is definitely going to be 16. Okay, definitely going to be 16. And let's have a look then. So the probability then of getting a diamond given one of these, ace, king, queen, or jack. Well, you could have then ace of diamonds, king of diamonds, queen of diamonds, jack of diamonds. They're the only diamonds from these 16 cards, so that's going to be 4 out of 16. And I would expect us to cancel that down to a quarter, but they haven't here. So 4 out of 16, there's our correct answer. Let's just have a look at our incorrect answers then up here. So I'll just write on these up here. Our incorrect answer, this one was done worse, and I can see what's happening here. People are choosing, I think, probably the correct 4 cards, the ace of diamonds, king of diamonds, queen of diamonds, jack of diamonds. So the 4 is correct there, but the 52 isn't, because it's not out of all the cards now. It's out of just the 16 cards that are ace, kings, queens, and jacks, because we're given that that's all we're choosing from. Okay, this one here, I'm not quite sure what's happened here, but I think probably that this is just maybe ignoring the bit about diamonds, and it's not read the question properly perhaps, and this is the probability here. That works out to be the probability of an ace, king, queen, or jack from the whole pack. So that, I think, is what's happening there. But again, that's not answering this question. It wants the probability of a diamond, given that we're just looking at these 16 cards. Okay, so that was the one that was done worst. Make sure you've got that in your notes, please. And I'll attach these questions to the task. Okay, our next question here. I think here probably if people were trying to just do this on their phones and didn't have a piece of paper with them, it becomes a little bit complicated because you miss some of the solutions here probably. I'm going to draw a little tree diagram here to help with this, and that's what I would hope you would do in the exam. Looking at this then, A is the right answer, so well done if you got that one. And then B here is the most common wrong answer, and that was followed by D, which is also wrong. Okay, and C is wrong as well, but not many people put that. But I can go through where that's come from. So let's have a quick look at a tree diagram here, because there's 2 things that's going on. She sits a French test, she passes or she fails. Then she sits a German test, she passes or she fails. So let's have a look at this. We've got our French test. I should be using a ruler really, but I just want to do this quite quickly. Then we've got our German test. And then I'm going to do this. And I want you to get into the habit of doing this, if you haven't been doing that, is to writing out what outcomes these are, because it's much easier if you write them out here to then pick out what you want in the question. Okay, so she's going to pass or fail French, and then she's going to pass or fail German. And our outcomes then are she passes French and she passes German, she passes French, she fails German, she fails French, she passes German, or she fails both. Okay, let's put some probabilities on this. Probability of her passing French is 0.8, so that must be 0.2 for failing French. If she passes the French test, that's up here, then the probability she passes German is 0.85. So this one must be 0.15. And if she fails French, so down this branch, if she fails French, the chances of her passing German is just 0.15. So then the probability of her failing German is 0.85 there, because these pairs have all got to add up to 1. And we've got our outcomes here now. Okay, and now it's about reading the question again really carefully, understanding what this means. And this at least 1 comes up in the next question as well. So at least 1, what does that mean? That means she passes one of the tests, or she passes both of them, because at least 1 means 1 or both. Okay, there's only 2 tests, so she either passes 1 or she passes both, because it's at least 1. It doesn't say exactly 1, it says at least 1. So if we're looking at this then, the probability down here that she passes at least 1, so that's going to be the probability she passes both of them. So here's our outcomes, because she's passed at least 1 there, she's passed 2. She passes French but fails German, because she's passed at least 1 here. Or she fails French and she passes German. So that's the probabilities that I need. So here what we'll be doing, probability of pass, so that's going to be 0.8 times 0.85 plus, so an all probability, so all this one, so 0.8 times 0.15, or fails French but passes German, so she's passed at least once, 0.2 times 0.15. Okay, and if you sort all of that out on your calculators, you should get 0.83, which is answer A up here. Okay, let's just have a look at where these wrong ones I think have come from. So this one looks like the probability of passing German. So this one I think is pass here, or fail pass here. Okay, so passing German basically. And I think if you're not drawing a tree diagram, it's easy to miss a combination here. So pass, fail pass, but it's missed out this one where she passes French but fails German. Okay, so that's what's happened there. And this one here, this one is the probability. I'm not quite sure why people have only chosen this one, but again, I think it's if you haven't drawn this out, you might miss some of the combinations that give you at least 1 pass. So this one here, 0.12, is the probability that you pass French and fail German, I think. So pass French and fail German. Okay, so again, I think here it's just about not writing these different combinations out, so just thinking that's the only way to pass at least 1. Okay. In fact, no, let me just check. 0.12 is no, it's fail French, pass German, so it's this other one here, down here. So fail French, pass German, I think gives you that probability there. Let me just get my calculator. Just get my calculator and check that, just to make sure that people who got this one, I can see where that's come from. No, I was right the first time. So this probability, sorry, is pass French, fail German, but it's only including that one outcome. It's not all these others. So when you get one of these questions, always a good idea to draw a tree diagram, and then make sure you're reading the question carefully and getting all the outcomes you need. Okay, last one of these. So this next one, which was the next most commonly wrongly done, but not as bad as those first two. And this one is question, this was actually question 1 from the tree diagram questions. And again, I think it's just because people are maybe trying to do it on their phone, not got a piece of paper with them, not writing out our outcomes. So I want on this question to write our outcomes here, because I think if you do that, it's really easy to get this question right. So let's have a look at this. This outcome at the top, win football and win rugby. This second one, win football but loses rugby. This third one, loses football but wins rugby. And this final one, loses both football and rugby. And then which lines show the probability of winning at least, so there's that phrase again, at least one of these games. So winning at least one. Win-win, we've won both. Win-lose, we've won once, football. Lose-win, we've won once, rugby. So it could be any of these. So those are the lines that show the probability of winning at least once. So that's why D is correct. The most common wrong answer here is B. I think if you write these outcomes out, you read the question carefully, this is reasonably straightforward now, hopefully with that explanation. This one, B, 2 and 3, lines 2 and 3, that's the most common wrong one. And again, I can see where it comes from because this is winning exactly one. Okay, so that's the probability of wins exactly one, but not at least one, because at least one includes the fact that we could win both. So there's our common misconceptions from that last EEDI quiz or two. Please make sure, I'm going to attach these to today's task, so please make sure that you get these into your notes as examples, a bit of recall of tree diagrams in particular.